is called 2a, and the vector O to B is called B. M is the midpoint of A to B, and we need to find the vector O to M. So we can say that A to B, to get from A to B, we can go minus 2a. So O to A is called 2a. A to O, going backwards along it, is called minus 2a. Plus B. So A to B is called minus 2a plus B. A to M is half of A to B because it's the midpoint. So A to M is half of this vector, so half of minus 2a plus B. So that's going to be minus 1a plus half of a B. So that's A to M. We want to go from O to M, so we're going to go O to A and then A to M. So O to M is going to be O to A, which is called 2a, and then A to M, so then minus A plus half of a B. So collecting our like terms, we've got 2a minus A, which is 1a. So we've got A plus half of a B. Okay, one for you to try. So again, we're looking for the vector O to M. So just as before, we can say that A to B is, we're going backwards along O to A, so this time it's minus 3a plus 4b. A to M is half of that, so minus 3 over 2a plus 2b, and O to M is 3a and then A to M, so 3a minus 3 over 2a plus 2b. 3 minus 1.5 is 1.5. So we've got 3 over 2a plus 2b. This time, we are told that P is a point on AB, such that A to P is one part and P to B is two parts. So P is 1/3 of the way down A to B. There are 3 parts in total. A to P is one part and P to B is 2 parts. So we can say that A to P is 1/3 of A to B. It's 1/3 of the whole journey. We need to find the vector O to P. So let's find A to B first. A to B is minus 2a plus b. So A to P is 1/3 of this. So 1/3 of minus 2 is minus 2/3. And 1/3 of b is 1/3 b. So that's A to P. We want O to P. So it's going to be 2a and then A to P. So to go from O to P, we're going O to A and then A to P. So O to P is 2a minus 2/3 A plus 1/3 B. 2 take away 2/3. 2 is 6/3. So 6/3 take away 2/3 is 4/3. So it's 4/3 A and 1/3 B. And one of these for you to try. So give this one a go. This time P is 1/4 of A to B. So we've got A to P is 1 part, P to B is 3 parts. So we can imagine this is cut into 4 parts. So A to P is 1/4 of A to B this time. It's 1/4 of the whole journey. So A to B is minus 5A going against the 5A arrow plus 2B. So A to P is 1/4 of this. So a quarter times negative 5A is negative 5/4 A. And a quarter of 2, that's a half. So plus a half B. So that's A to P. We want O to P. So we're going to go O to A and then A to P. So it's 5A plus this answer. So O to P is 5A minus 5/4 A plus half of a B. 5 take away 5/4. So 5 is the same as 20/4. So 20/4 take away 5/4 is 15/4. So it's 15/4 A plus half of a B. Here's another example. This time we are proving that something is a straight line. So we are told that C is the point on O to A, such that O to C is 3 parts and C to A is 1 part. So C is on O to A, O to C is 3 parts, O to A is 1 part, so there's 4 parts in total. The whole line is called 4A. So O to C must be 3A and C to A must be A. M is the midpoint of AB. So M is halfway along AB. And D is the point such that O to B is 2 parts. It's 2B, 2 parts. And O to D is 3 parts. So if O to B is 2 parts and it's called 2B, each part must be a B. So O to D must be 3 B's. So O to B is 2 B's, B to D is another B. So the whole journey is 3 B's. So O to B is 2B, O to D is 3B. We need to prove CMD is a straight line. So from C to M to D, they all line up. And we can do this by working out C to M. If we work out what C to M is, and if we work out what C to D is, we can show that it's a straight line if they're going in the same direction. So they both go through C, and if they're going in the same direction, it must be a straight line. And if they're going in the same direction, that would mean one is a multiple of the other one. They're in the same direction, just one's bigger than the other. So let's work these out. So let's go from C to D will be easier. We'll do C to D first. So to go from C to D, we're going minus 3A plus 3B. And then C to M. To go, well, we want to go C to A and then A to M. To work out A to M, we have to go A to B first. So let's get A to B, which is minus 4A plus 2B. A to M is half of that, because m is the midpoint. So minus 2a plus b. And so c to m is going to be a plus a to m. So c to m is a minus 2a plus b. A minus 2a is minus 1a, negative a, and we have a b as well. So c to m is negative a plus b, and c to d is negative 3a plus 3b. So we can see that c to d is just 3 times c to m. So they're going in the same direction, it's just 3 times as far. If we did minus a plus b 3 times, we'd do minus 3a plus 3b. So it must be on a straight line. So we can say they both go through C and they are in the same direction. Therefore, it's a straight line. Okay, a similar question for you to try. So give this one a go. This time we have a parallelogram. We're told M is the midpoint of CD. So M is the midpoint of CD. P is the point on A to C. So let's draw A to C. P is the point on A to C, such that A to P is 2 parts. So 2/3. And P to C is 1/3. Prove that BPM is a straight line. So from B to P to M. So if we work out B to P and B to M, they both go through B, and if one's a multiple of the other, then they must be on a straight line. So let's go from B to M first. That looks easier. So B to M is 6B and then minus 2A. So the opposite lengths of a parallelogram are equal. So A to B is 4A. So D to C must also be 4A. So B to M is 6B and then backwards 2A, minus 2A. So that's B to M. How about B to P? So if we go A to C, which is 4A plus 6B, A to P is 2/3 of this. So A to P is 2/3 of A to C, 2/3 along the line. So 2/3 of 4A plus 6B. 2/3 of 4A will be 8/3 A. 2/3 of 6B will be 4B. So that's A to P. We didn't want A to P, did we? We wanted B to P. So it's going to be minus 4A plus our last answer. So B to P minus 4A plus 8/3 A plus 4B. 4A is, so 4 3s are 12, so it's 12/3 minus 12/3 of an A plus 8/3 of an A plus 4B. 8/3 minus 12/3 is minus 4/3. So we've got minus 4/3 A plus 4B. And we had B to M as 6b minus 2a. We've got b to p as minus 4/3 a plus 4b. So is one a multiple of the other? So to go, I'll write this the other way around. So we've got 4b minus 4/3 a for b to p, and b to m was 6b minus 2a. So we can see that if we multiply b to p by 1.5, 1.5, we'd get b to m. So we can say that b to m is equal to 1.5, or 3/2, times b to p. So they both go through b. And same direction. So it is a straight line. And to finish up, we've got one more question. So pause the video, give it a go, and press play when you're ready for the answer. So we've got C on the point O to A, such that O to C is 2 parts. So O to A, O to C is 2 parts, C to A is 1 part. M is the midpoint of AB. D is the point such that O to B is 1 part, O to D is 2 parts, so it's half. It's a B on each side. O to D is double O to B. Prove that CMD is a straight line. So let's go from, we're going to go C to M and C to D. So go C to D first, that's easier. So it's minus 2/3 A plus 2B. And to go from C to M, we'll have to work out A to B first. So A to B is minus A plus B. So A to M is half of that, minus half an A plus half a B. And C to M is C to A, which is 1/3 of an A, plus A to M. So minus half an A plus half a B. So double the top and bottom of the first fraction. So 2/6A times top and bottom of the second one by 3 minus 3/6A. And we've got plus half a B on the end. 2/6 take away 3/6 is negative a sixth. A plus a half B. So there's C to M. And we've got C to D over here. So is one a multiple of the other? So C to D, or no, C to M times 4 makes C to D. So C to M, 4 C to M's equal a C to D. So they are on a straight line because they both go through C. And they go in the same direction. One is a multiple of the other, so they're in the same direction. Therefore, it is a straight line.